Ooh, I just realized you couldn't hear me. Thank you, Shivam, for mentioning that you couldn't hear me. I had myself on mute and I was talking there. So let me back up a little bit. This is the agenda that we'll be doing today. So what I was saying to myself is today's class is very similar to yesterday's. It's a 3-hour class, 2 hours for content, 1 hour for the exam. And today is going to be primarily or completely lab-based. So we're going to be doing labs together. Yesterday we did, or I did a demo and then we did labs. Today is 99% lab. So we'll be doing some basic things with searching and parsing to start. And then we'll start to get more complex as the day gets longer or goes on. And then we'll take that certification as we did yesterday. And if you didn't take it with us yesterday, we'll go over the details on it later. So don't worry about it. This is a reminder of the promotion we're doing. Where it says for Uber Eats, but for India, we're doing it with Swiggy. So if you take a certification class, which you're doing now, if you take the certification exam and pass it, which you may have done yesterday, and send that to us, you'll get a $15 voucher for Swiggy. If you did one yesterday and did one today, then you get 2 vouchers. Some of you may have had an issue yesterday submitting the form, particularly uploading a portion of the certificate. If you did, you should be able to do it correctly now. Basically, we removed one of the requirements that you had to upload the certificate. So I know some people, as I was leaving last night for me, had some issues submitting that form. So once again, if you did, just retry it. Once again, if there's more questions about it, we can talk about it later, of course. All right, so I'm going to skip over this slide. I went over this yesterday. Basically, Sumo Logic can help you in a variety of different ways, whether it's operational intelligence, security intelligence. We're going to be looking at kind of operational and a little bit of security today. And then regardless of what type of data you have and where it is, you can bring it into Sumo Logic and then use our analytics to start to explore that data. And that's what we're going to be doing today, is using some of those analytic features. And then really kind of the last slide here is the Sumo Logic data flow. This is one I also showed yesterday. And just to kind of rehash it, the 3 steps or phases, if you will, to Sumo Logic. The first step is data collection. We talked about that a little bit yesterday, and I keep alluding to yesterday. And if you didn't attend yesterday, that's fine. You missed something, but you're still going to be okay for today. But the data is going to be brought into Sumo and collected. So that's step 1. Now, step 2 is where we're really going to be focusing on today, and that's searching and analyzing and using the query language to start to slice and dice your data and using the operators to do things with the data, essentially, and representing it in charts and dashboards, as we saw yesterday. And then that step 3 is visualizing and monitoring. We will look at alerts today. We won't really do much with dashboards today. We did those yesterday. So we'll be focusing primarily here on step 2 and 3 today. Suresh put a good reminder in the chat there. And I kind of I think I had myself on mute when I did the introduction. So if you have any questions today, go ahead and post them in the chat or the Q&A. Probably Q&A is best. And Suresh and Poonam are both assisting, so they'll be able to help you with any questions you have. All right. So let's get going. Let's dive in here. So we're going to use the same credentials we used yesterday. If you don't remember them or didn't participate yesterday, that's fine. If you did, you kind of know where I'm going with this. But what we're going to do now is log into Sumo Logic. And I've put the credentials in the chat. What I want you to do is you go to service.sumologic.com. For the email account, I want you to use training plus analyst number. So I want you to select a 3-digit number. It could be the 3-digit number you used yesterday. It doesn't have to be. It doesn't matter if there's overlap. We have a pretty small group today. So go ahead and utilize that. So maybe you want to be training plus analyst 234 at sumologic.com, which is what I usually use. Training plus analyst 123 at sumologic.com. Training plus analyst 007 at sumologic.com. Pick a 3-digit number. The password we're all going to use is going to be learning 22 exclamation point with a capital L. So capital LEARN ING 22 exclamation point or bang. And once you get logged in, if you could go ahead and put your number in the chat. Thank you, Shivan, for doing so for us, starting that off. So that way I can just confirm that you have logged in. If you need help, let us know. It's probably going to be a typo, just to be honest, but that's okay. So go ahead and let's get in there. I'm going to log in as well. So if just let me go ahead and do the same thing. So service.sumologic.com, training plus analyst 234 at sumologic.com. And I think Hitesh is using 234 as well. So that's cool. We'll use the same one, not a problem. And then for that password, learning 22 exclamation point. So once again, go ahead and log in. Once you get logged in, you should see this screen that looks familiar, especially if you had joined yesterday. As a reminder, if there are a bunch of tabs opened, go ahead and feel free to close those. So ultimately, I'd like you to get to a screen that looks pretty similar to this. This black bar, you can probably hide a bunch of it. We're not going to be using it too much today. And the other portion I want to add to what you're doing right now is I want to point you to the labs. I'm going to put the link in the chat for the labs. So go ahead and open that link. And so what that link should take you to is, well, not this screen. There we go. This type of screen. And so what we have here are the labs we're going to do. There's 13 labs here. We'll probably do all of them. We might skip one or two, just kind of depending on time. But we'll do most of them. All these labs, or many of these labs, have sub-components. So even though it says 13 labs, it's probably going to be about 20 or 25 labs we'll do together, which is a lot. And we'll start with lab 1. So I'm just going to kind of pause for a few moments again, make sure everybody that's logged in, that wants to log in, can. If you can't log in or don't want to log in, you're welcome to just follow me. I'm going to be doing the queries on the screen, so you'll still benefit from them. Yeah, I'll just go and wait just another moment or two. And once again, if you can't log in or you need help, Suresh and Poonam are there for you. So please utilize them. But I'm going to assume everybody's, I think we're together. So where we should be right now is we should be, let me get rid of this one. We should be logged into Sumo, and we should have our lab page or document open. All right. So assuming that's the case, let's begin. So we're going to start with lab 1. Lab 1 is going to be search basics. This is, for some of you, this is going to be very basic, but that's okay. We need to start somewhere. So what we're going to do is do some keyword searches and metadata. We're going to use both, actually. And we started to explore metadata yesterday. Metadata is going to be the source category. It's also can be other data, but primarily for our use case, it's going to be the source category that we're going to utilize. Now, for today, for these labs, we are not going to be creating queries from scratch. I hope that's not a disappointment for anybody. For this class, I found that this method of utilizing the queries and seeing how they work is going to be helpful. So if you hope or plan to create queries today, that's just not really the focus for today. But what we are going to do is use the queries that are here. So for each query, or most of them, they're going to have kind of like almost like a math word problem, if you will. And then we're going to solve it. So let's start with query or lab 1-1. So this is going to be lab 1-1. So what we want to do in lab 1-1 is search for all messages with the source category of Lab Apache Access for the last 15 minutes. So how do we do that? Well, very, very simply. We're going to grab the query, going to copy it, going to go into Sumo, going to do a new log search. And we're going to be doing a lot of new log searches. You'll probably do about 20 of them today. And I'm going to paste my query in. I'm going to click search, and I'm going to run it. By default, the time filter is set to 15 minutes. So that fulfills this portion of the request, or what we're trying to solve. And we're looking for Lab Apache Access data. And so what I should see is Lab Apache Access data. And I should see roughly 7,000 results. I might see more, I might see less. If I click start, my 15-minute window is such. If you click start a few seconds later, your 15-minute window is a little bit different than mine. And so your results might be a little bit different than mine. And that's okay for today. So it's not important that they match exactly, but they should be close. So as a reminder, we see the source category we want or the query we want. We see the middle histogram here. This histogram is taking the 15-minute period or whatever the period is that we've defined and splitting it up into logical time chunks, I guess is a way to describe it. And so basically there are 15 periods that are each 1 minute. So by using this histogram, we can see from 9:36 to 9:37, there were 635 messages. From 9:37 to 9:38, there were 509 messages. In some cases, this histogram is going to be helpful in a good visualization of what's going on. In some cases, it's not, but it's there for you. And then as a reminder, we see the log messages down below. By default, for every log message, we're going to see the message itself. And then we're going to see the time that has been extracted from the message, which is probably, or not probably, is going to line up with this time right here. And we've done a search, a very basic one, but a search nonetheless. Now in 1-2, we want to get a little bit more advanced. What we want to do here is we want to identify client errors. And so what we want to look for is a 404. This is Apache data. We used it yesterday. Apache data is web server data. When you go to a website, this is basically a capture of that transaction or that experience. When you go to a website and you got a file not found, page not found, that's a 404 error. And so that's what we want to look for here. So how do we look for 404s? Very simply, we're going to copy the query and paste it in again. I'll do a new one just because I keep doing that. But what we're doing here is we're using the keyword. So we're still doing the Lab Apache access like we did earlier, but now we're adding end 404. When I click start or search, I'm still looking for that Apache access data, but now I'm looking also for the keyword or the string of 404. Any results that have it are going to be retrieved. Any results that don't match will not be retrieved. Another thing, just real fast, or not real fast, but just to point out, the word end is not required. So I can remove it, and if I run the query, it's going to be the same exact thing as if it is there. So you can put the end in or leave it out. It's up to you. As a new user, you probably want to put it in to remind yourself that it's there, but if you don't have to. Another thing I should have pointed out, probably even yesterday, is as you'll notice, or may notice, the query language is very similar to SQL, so SQL. If you've used SQL before, you kind of know the language, and you'll see that shortly, in that you can do where statements and things like that. So that might help you for some of you that have that experience. All right, let's go to lab 1-3. In 1-3, what we want to do is introduce the idea of Boolean logic, and we want to look for log lines that match multiple criteria, that match error, or check out. So how do we do that? Well, grab the query, copy it, paste it. But what we're doing here is we're saying, look for the Lab Apache access data, again, as we've been doing, and this time look for the word error, or specifically the string, if we're being correct, or check with the star. When I click start, any message that has that criteria that matches this portion, as well as this portion, will be displayed below. And so that's why I have checkout here, checkout here, checkout here, etc. All right. Let's keep going. In 1-4, what we want to do here is we want to look at a new source category, or new to us, we haven't done it yet. And we want to look at the data for the last 45 minutes. So once again, I'm going to grab the query. I'm going to do another new log search. I'm going to paste it in. Now, in this case, I wanted to look for the last 45 minutes. How do I do that? Now, you might know, and if you do, go ahead, but let's show you if you don't. As a reminder, here is my time selector. It defaults to 15 minutes, but I can modify that. When I click on it, I have the ability to modify it using these relative time periods. Last 15 minutes, last hour, last 3 hours, etc. Yesterday, today, so on and so forth. Now, I don't have the last 45 minutes in here. So while this is helpful to show, this is not the solution to this lab. I also have a custom option here where I can use a calendaring feature. And so I could say, show me all the data from March 15th to March 22nd from midnight to midnight. But that doesn't do the last 45 minutes, although it could, but it would be kind of granular. But what I can do is, if you notice when I click up here and select, for example, last 60 minutes, I have this syntax of minus 60M. If I select last 15 minutes, I have the syntax of minus 15M. Well, if I want to do last 45 minutes, minus 45M. And now I'm looking for the last 45 minutes worth of data. Now, I don't know, I might have been on pause or mute when I mentioned this. I am based in the United States, so my time right now it's 9:30, your times might be different. But what I see now here is for our last 45 minutes, here is all our data. And so I wanted to introduce that with this lab, the time ability. If you want to search for the last 33 minutes worth of data, the last 18 days, you have that ability. So you can get quite selective. All right, let's now look at lab 1-5. What we want to do in lab 1-5 is we want to look at two different source categories. We want to look at Lab Apache access data as well as Lab Apache error data. Now, what I'm going to do is copy this query, as I've been doing. This is not really a new step. But before I run this, I want to kind of quiz you on this, I guess, or at least have you think about this. So what would happen if I remove the OR and I run the query like this? What results am I going to get back? Am I going to get back Lab Apache error data? Am I going to get Lab Apache access data? Am I going to get both sets of data? Am I going to get no data? Just think about it for a second. All right, Raul said nothing. Let's see if he's correct. Well, he is. So let's see why he's correct. When I click search, as you guys are starting to figure out, I get no results back. Now, why do I get no results back? The reason I get no results back is since there's nothing here, it's as if an end is here. And with the end being here, it's as if I'm saying, look for data that resides here and resides here at the same time, and data can't reside in two different places at the same time. So that's why we can use the OR where we're saying, look for data in one place or the other. And that's why we then get both sets of data. So just a little, like I said, little quiz there. So good to see, yeah, many of you got it correct. So glad to see you're thinking about it that way. Now, what we can do also here in lab 1-6 is represent this statement a little bit differently using wildcards. And so that's what I'm doing right here is I'm going to do plus new, as I've been doing, Lab Apache star. And now I am getting Lab Apache access data as well as error data. I can confirm that or verify that using this field browser. This portion right here that hopefully you're seeing me move my mouse around is the field browser. What the field browser shows us are those fields that Sumo Logic is aware of. We'll talk about a little bit later how it's aware of those. Yeah, we'll talk about that a little bit later. But what I see is what it's aware of. And so what I can do is I can look at these. So for example, here with source category 2, that means that for this set of data, it found 2 source categories. What are the 2 source categories it found? Lab Apache access and Lab Apache error. So wanted to show this field browser. We'll be using it a few times today, but this is a good intro to it. All right. This last step here, I am going to do real quickly, and I'll explain why I'm going to do it real quickly, and then you can do it. So let me do this real fast. There's a reason I'm doing this. Okay. Let me just make sure it runs. There we go. Perfect. All right. So what did I do? Why did I rush? What am I showing in lab 1-7? What I want to show you and introduce is a feature that we call live tail. Now, when I don't use live tail and I run a query like Lab Apache Access 404, like we did in lab, I think this second step, I'm looking at old data. Now, Old is relative, but it's data that's come in, it's been ingested, and it's potentially been sitting around for up to 15 minutes. Now, that's not bad. That's usually the data you want to look at, but that's one option of looking at data within Sumo Logic. What I want to introduce here is a feature that we call LiveTail. What LiveTail lets you do is look at data as it's coming into Sumo Logic, before it's been ingested, before it's been processed, just as it's coming into the system. And that's what this LiveTail is showing right now. So what I'm seeing here is each line is data coming in, coming in, coming in, and so on and so forth. This is a helpful feature for some of you. Some of you will never use this feature again, and that's perfectly fine. But some of you will use this feature and like it quite a lot. Where it becomes quite helpful is if you want to see your data as it's being ingested. So let's say we talked a little bit about collection yesterday, I'll touch about it today. Let's say you set up your collectors and you start to ingest your data and you think you're ingesting data. Well, coming to this LiveTail is going to be helpful to see, is data actually arriving? Is it being processed? If nothing is showing up on the screen, then you have a problem. Your data is not coming into Sumo Logic properly due to whatever, troubleshooting things. But if it's coming in and hitting the screen, this is a positive sign that it's arrived, it's hit your account, and then it will be processed. The reason I rushed to show it, and some of you might be finding this, is there is a limitation of how many LiveTails you can do concurrently or at the same time. And there's a limit of 10 per an account. And so we have about 20 people here, so we might be hitting that limit. So that's why I wanted to just kind of get in front of it and show it to you. So hopefully you get to experience it. If you're trying to use it and you're hitting that limit, just come back to it in probably about 5 minutes as we move on to the next lab, and this one will be free for you to try. All right. So that concludes lab 1. We have some quiz questions. I'll go through them. I think they'll be helpful for you. And of course, as you've been doing, if you have specific questions, please ask. So for the quiz, let's do these. These are going to be true or false questions. So the first one, true or false? Keywords are case sensitive. So this is actually false, and we actually didn't look at this. So let's go ahead and look at it. So let's see here. Let's find one. So when we were looking for check, what I'm doing here is I'm putting check in all lower. Check with a star. There we go. Now let's see what happened if I start messing with my cases. And so it's insensitive. I can do all upper, all lower, camel case, whatever. And so that one is false. And is implicit and or is explicit. This is true. So and is implied, or you actually need to specify. So true. Yep. And then this next one, this is a little trick one actually. Keywords and metadata can use wildcards for LiveTail. So this is true, but it actually depends a little bit where you use the wildcard. So for example, this is probably a bit overkill, but if I do the lab Apache star, that will work. And you'll see it in a second. Hopefully. Come on, should work. Yeah, there it goes. Okay, so that works. If I do lab star access, that does not work. So the wildcard needs to be kind of at the end of the filter. It's a little kind of weird, subtle thing. So wanted to point that out. So this is true. All right, let's go to lab 2. So lab 2 is, as the title says, parsing, grouping, and filtering. We started to look at parsing yesterday. We're going to look at parsing a bunch today in both lab 2 and lab 3. But let's go through this. So what we want to do now is we want to take our data using our operators, or actually start to use our operators. We haven't really used an operator yet. And the first operator we're going to use is going to be count. So what I want to do in lab 2-1 is I want to grab the whole query. I'm going to copy it. I'm going to bring it into a new log search. I'm going to paste it in. And what I'm going to do is I'm going to do 2 slashes on the second line. And what those slashes act as are comments. And basically, I'm telling the system, do not run the second line. So what I'm going to do, and I'm going to do this a lot today, is run the first line, look at the results, explain the results, and then run the second line and explain what's going to occur. And I'd encourage you to do the same process. I think it demonstrates what we're trying to show here. So in the first line, what I'm looking for is all my Apache data. And as we saw earlier, there's Apache access data and there's Apache error data. But in this case, I'm saying bring all the data back. And I have that data. What I want to do now is I want to introduce, I think, the first operator for today, which is going to, well, I guess and and or are operators, so it's not the first operator, but count is an important operator. With count, what we're going to do is we're going to take our sources, our 2 different sources of data or unknown number of sources of data, and count them. So when I click start, I'm going to have a new tab called aggregates. The reason I have a new tab is because I'm doing math. Count is a mathematical operator, a very basic mathematical operator, but still an operator. And so what I now get is the results of that math in the aggregates tab. And so what I see are the sources, access and error data, and I see a count of them. And this count is representing the amount of messages. So over the last 15 minutes, there's been 7,000 access messages and about 2,000 error messages. And that's what this query did. What we're going to do now is get a little bit more advanced. And well, we're going to get a lot more advanced today. I'm going to grab this next query, and like I've been doing, I'm going to do a new log search and paste it in and go through this process again. So what I'm going to do is run that first line again. Now, what we want to point out here now is we want to look at IP addresses. So we're looking at our Apache data, and our Apache data may or may not have IP addresses. For example, here's an IP address. Here's an IP address. Here is an IP address, and so on and so forth. And here's an IP address. And the difference here is this is an Apache error message, and this is an Apache access message. Now, how do we tell the system to identify an IP address? As I mentioned and kind of joked yesterday, I recognize this as an IP address, and I hope you do too, but we want the system to do so. So how do we do that? Well, what we're going to do, and there's many ways to do this, but we're going to show you one way to do this, is to parse using regex or regular expressions. Regular expressions or regex or regex, depending on how you pronounce it, is not a Sumo logic thing in that we did not create it. We don't want credit for it or blame for it. It's an outside language almost at this point, or yeah, it's almost its own language. What it allows you to do, or anybody to do, is create a pattern matching system. And so that's what's occurring right here. What we're doing is we're saying parse, create a field using regex. The field I want to create is called IP address, or more specifically IP underscore address. Now, how do I want the system to identify an IP address? How am I going to train it? What I'm going to do is use this syntax right here. And what this syntax here says is essentially look for a number with 1 to 3 digits, dot number with 1 to 3 digits, dot number with 1 to 3 digits, etc. So now when I click start, the system is going to go to the first log message and say, essentially, can I find number dot number dot number dot number? If I can, go ahead and retrieve that as an IP address. Then go to the next log message. Can I find an IP address? Yes, I can. And there's my IP address, and so on and so forth. So now I've parsed out these IP addresses. The system knows what an IP address is, or at least how to identify it. And now what I can do is now count those IP addresses. So how many IP addresses do we have, and how many are unique, or how many times do they show up, I guess is a better way to say it. Count by IP address. I have that new tab for aggregates. And now I have all the IP addresses, 25 per page. And I have a count for each one. By default, the count is not going to be sorted in any order. I can go ahead and click on the count to look from high to low or low to high. And now I see this IP address showed up the most times. This one showed up the second most times, and so on and so forth. All right. Now, the next thing we're going to do here, and this is where SQL, well, you might even already recognize SQL-esque things, but what we're going to do now is we're going to use a where statement. And so the reason we want to do is, for example, here in this list of IP addresses, we have IP addresses that show up 700 times. We have IP addresses that show up 10 times. What if we only want to see those IP addresses that show up 500 or more times? That's what this last line is doing. Very simply, we're taking our count and we're saying where the count is greater than 500. When I run this, IP addresses that are 500 or greater will stay, and those that are 500 or less will drop. I can, of course, change this number to anything I want. I could change it to 100. I could change it to less than. I can change these around, but now I'm starting to filter my data based on the count. So very simple way to filter. You could also do a distinct IP. That would work as well. Getting a little more technical, but good question. Another good question here is, what is the difference between this count and this count? Why is this count just the word and this count the underscore? See if anybody knows, and if you don't, that's fine. But let's explain why. What happens here is when I count by IP address, the results of that count of that operator are called underscore count. It's essentially like a reserved word almost, if you will. And so that's why I now say where underscore count is greater than 100. I can't say where count is greater than 100 because the system doesn't know what a count is. It knows what an underscore count is, which are the results of a count. So hopefully that makes sense. We'll see another example of the underscore reserved word eventually. I think it's in this class, so keep an eye out for it. All right, let's go to, and then the other portion of this lab, excuse me, I'm getting ahead of myself, is the ability to utilize a pie chart. So when I ran this, however I did it, I get my results. Well, in this tabular view, these are how the results are displayed automatically, but maybe you would prefer a bar chart, or as we're recommending, a pie chart. And so very simply, I now have a pie chart. It's very easy to create, and that's how good this lab is to help you with something like that. So I wanted to show that. All right, now let's go ahead and take a look at lab 2-4. What we're going to do here is, I mean, as it says, we're going to take a look at IP addresses, and we're going to group them together by or around bandwidth usage or size. So let's dig into this. Let's see what we're doing here. So like I've been doing, I'm going to grab the whole query, and then I'll talk through it. So once again, new log search, paste. I'm going to do the slashes again, and I'm going to run through this. So the first line, source category lab Apache access, is and should be very repetitive. The next line we saw already as well. So what we're doing as a reminder is we're now looking at the Apache access, and now we want to look at IP addresses or define IP addresses. And so that's what we're doing once again with the regex. And now we have a field for IP addresses. Now, the next step here, what we want to do is we want to identify the size. And we sort of looked at this yesterday a little bit quickly, but what we're looking for is this value right here. What this represents is the size or the bytes. So when you went to a website, how many bytes were transacted back and forth, or really it's one directional or unidirectional, but how many bytes were transferred? So how do we get the system or train the system to look for this 4-digit number here? Well, what we're going to do is we're going to use parsing again. Now, this time we're going to use a different method of parsing. What we're going to use the parsing method here is called parse anchor. What this parse anchor is doing is going to rely on a portion of the log message that's going to be static or not change. And so here is a description of what we're looking for. We're looking for a space. We're looking for a 200. We're looking for another space. And then that next thing is going to be the size. So where do I see that in a log message? Here's a space. here's the 200, here's the space, here's that 4-digit number. So when I run this query for the third line, I should now get a new field called size, and I should get these 4-digit numbers in that size field. So let's see if I do. And I do. So now for each log message, I have an IP address and a size. I might have multiple IP addresses here with different sizes. I don't really know. I have 220 pages of them, 5,000 results, so I can't really tell that. But now I want to start to figure that out. What I want the system to do here is take the sizes and add them up and call the added up sizes total bytes. And I want to do it by IP address. So what I want it to do is for this IP address, if there's other sizes, add them all up. So let's run this. When I do sum, that's a mathematical operator. I'm going to get that aggregates tab again. And now what I see is each IP address and the total bytes, all those 4-digit numbers added up. Once again, I can sort these if I'd like to. But what we want to do in the next step is we want to use a sorting mechanism coded in rather than us just manually clicking on the sorting here. What we want to do here is we want to take the top 10 IP addresses. And so very simply, top is an operator. We can take the top X, the top what, the top 10. We want to take the top 10 IP addresses. Now, do we want to take the top 10 IP addresses by count? No. Do we want to take the top 10 IP addresses by status code? Nope. We want to take them by total bytes. So what's going to happen now is the system is basically going to look for the total bytes, look for those with the top 10, keep the top 10, and drop the bottom whatever. And now I have that here. So what we were showing here is two different parsing mechanisms within the same query. We're actually going to look at a few more parsing mechanisms in the next lab. We're using sum here, so that's a different operator that we've used before. We're using as here to essentially name this field or name the result here. And then we're using that named result in the last to filter our data. All right, let's go to lab 3. See if there's any questions. I think we're good. Yeah, let's on to the next one. So lab 3 is more parsing. So let's just go through these. For these labs, I'm going to show these a little bit differently. Feel free to run through the queries as they are. But lab 1, let me 3-1. Let me just show you what this does. The description here is probably more verbose than it needs to be. So what I want to show here is CloudTrail data. Specifically, well, not specifically AWS CloudTrail, there is no other CloudTrail data, but specifically AWS CloudTrail data. You may be familiar with this data type, you may not be. If you're not, that's fine. We're just going to be using it as a sample data set. And the reason we're using it as a sample data set is it's a little bit different than the Apache data we looked at. So let's see the difference here. So here is the Apache data. So here's a log message, here's a log message, here's a log message, etc. And as I showed you both today and yesterday, if we want to parse portions of this log message, we can do so using parsing, using that regex, using that parse anchor, a couple different ways to handle it. Now let's look at the CloudTrail data. Now here's the CloudTrail data. Here's message 1, here's message 2, so on and so forth. Now, if you notice, and you will because I'm pointing it out right now, the CloudTrail message, for example, has an IP address, but it also has a field called source IP address. This is AWS data, so it has a field for AWS region, and it has a value for this region. What I can do, since this data is in a JSON format, is the data can be parsed for me or is parsed for me automatically. Sumo automatically parses JSON data. And so if I wanted to, for example, count by all the different AWS regions, the system knows that this is a field. And so I can very simply say, count by AWS region. When I do, I get that aggregates tab and I see those different AWS regions with the counts. So this is a reason why utilizing JSON for your log messages is a good idea. There may be reasons that it's not a good idea. they're more verbose. We talk about this in the administrative course, but so this is something you can do. There's also the feature to auto parse mode. So what you can do is with this turned off, then you would need to do an auto JSON. So the question came up about auto JSON. So let's take a look at this. So if I don't use auto parse, then I need to do auto JSON, which is basically just enabling that flag. So good question. So let's see. I think that concludes lab 3-1. Yeah. Yeah. So like I said, JSON it's a good reason to use them. Let's take a look next at lab 3-2, -3, -4, and -5 all at the same time. And what I'm going to do is I'm going to grab the whole query in step 5 and just talk through it. Once again, feel free to go through each step on your own. And I'm just going to show it a little bit differently. So what I'm going to do is, once again, new log search, paste in the query, comment off a bunch of lines, and then talk about why we're doing this thing. So what we want to do first is we want to look at Lab Apache error data. And so I just want to make sure I have my data, and there it is. Now, what I want to point out in this data is these log messages. And what I want to point out is, actually, let me see here. Okay, here's a good example. Every log message in here, let's see. Yeah, okay. So every log message of Apache error data is going to have bracket and the time. Bracket and the time. It's then also going to have bracket, and either it's going to say error in it, it might say something else in it, but it's going to have bracket, something, bracket. Now, the next portion is what we're focusing on today. And that's each message is either going to have client space, actually specifically bracket client space IP address, or it's not going to have that. Okay, so some messages have an IP address in them, some do not. Now, what I want to do here is I want to parse those IP addresses. Now, I'm going to comment off this no drop because I want to show these steps one by one. Now, what's going to happen here, and I want you to think about this, when I run this query. When I run this, it's going to look for client IPs and specifically going to look for this portion. What is it going to do if it finds an IP address? What is it going to do if it can't find an IP address? So think about that just for a second. And let's take a look. So what occurs is the system is going to look at bracket client space. If it finds something, it's going to retrieve that and call it a client IP. Now, what happened to those messages that did not have a client IP? Those get dropped because they do not meet the criteria of the filtering or the parsing. So the parsing looks for matches and retrieves those matches and then continues on with the query. If it doesn't match, it drops them. What we can do here is we can utilize no drop to see those messages that are being dropped as well as those that are being kept. So when I run a no drop, what I see here is for each log message, if it has an IP address, the IP address is displayed. If it does not have an IP address, the message is still retrieved, but it doesn't display an IP address because there is no IP address to display. No drop is going to be helpful for you as you start to create your queries to make sure you're creating them correctly and use them. Use no drop for troubleshooting, if you will. Because imagine I've created this query looking for a client IP. And imagine I misspell client and I run this query. And I run this query as is with no. And I run this, sorry, I just clicked way too many buttons. So I run this query with client misspelled. And I don't realize it's misspelled. And I get my results here and I see that I have no client IPs. And I'm thinking to myself, why don't I have client IPs? And then I run a no drop, and I see that these messages are being retrieved. What it should start to tell me is the reason I'm not getting a client IP is probably because something in my parsing is not correct. And so I can start to use this for troubleshooting. I can also use this to pass the results back that do not have IPs. So if I want to filter on them or just retrieve them, I can do so. So no drops are a really helpful feature as you start to create your queries. I'd encourage you to run it, see what you're dropping. If it's things you're fine with dropping, then you're good to go. The next feature I want to show, and I'm kind of skipping one step in the lab, is this is blank. What this is blank is going to allow me to do is almost the opposite of a no drop. What I'm doing here when I run this is saying, show me only those places where the client IP is blank. And now when I get this, I only have log messages that did not have a client IP. So is blank is helpful. There's an is empty, is null. I think those are the three. So I wanted to show that. And that takes us through lab 3-5. All right, let's keep going here. A couple more parsing examples or features, or however you want to kind of describe them. This next parsing feature, once again, I'm going to grab the whole query and show it. This feature is it's pretty helpful. I'm just going to show it because it's probably the easiest way to describe it is showing it. In this case, I'm going to look at GitHub data. GitHub data is not Sumo Logic data. This is, I feel like everybody probably knows what GitHub is. Basically an external website where people can upload and download code, changes are tracked, that type of thing. And within GitHub, there's the idea of a committer, somebody that commits code, usually an individual, a person. And we can actually see information about that committer here. So here, for example, I see the committer was OnKit. I see his email address, other stuff. What I want to show now is the ability to parse out this email address. Now, there's a few different ways to do this. This is in a JSON format. We actually, this is not. Well, yes, it is, but we could do this a few different ways. But what I'm doing here is I'm specifically using the parse anchor again. So I'm saying, look for the word email, look for a colon, look for a space, look for a quote. Whatever's in those quotes is going to be the email. And so I'm going to run that. And what I should now get are a bunch of emails, except for that typo. So now I have a bunch of emails. So here's my email, etc. What we want to show you now is the ability for you to parse this data even further. What I can do is I now have parsed emails out. I can now take these emails and parse them even further out. And the way I'm going to do this is using the @ symbol as the anchor. And I'm going to say anything before the @ symbol is called the user. Anything after the @ symbol is called the domain. And that's what this third line is doing. It's looking at this field of email. It's looking for the @ symbol. Anything before it will be called users. Anything after it will be called domain. And so now when I click start or click search, I have two new fields created, one called domain, one called user. And now I could count by users or count by domain or whatever I want to do. In this case, I can count by users. And now I see all the different users that have committed or submitted code. And as we did earlier, I can use that top operator to say, just show me the top 5 users that have committed or submitted code. And so what we wanted to show you there is the ability for you to parse something and then parse it even further, which is a helpful feature. It may not be something you do every day, but you will do it at some point. So wanted to show that here. All right, on to lab 3-8. I hope I'm not going too fast for you. So let's look at 3-8. Once again, and 3-9 are the same. So I'm going to once again grab the whole query in 3-9 and just kind of talk through it. So new log search, paste it in, going to comment off this last line. I'm actually going to make 2 comments on there. And let's pull up this data and explain why this is a good example. In this example, what we're using is called snort data, S-N-O-R-T. This is once again not Sumo logic data. This is another external application or tool. This in this case is security information data, I guess is a simple way to describe it. Now, what I want to show you here is parsing for IPs as we did earlier. This is not new, but it's going to show something that might be new. So here I have my log message 1, log message 2, 3, 4, 5, so on and so forth. Now, in each log message, what I want to point out is the fact that there are 2 IP addresses. So here's the first log message. Here's IP1. Here's IP2. Second log message, IP1, IP2. What are the different IPs? For today, it doesn't really matter. They might be source destination, they might be host remote, primary backup, doesn't really matter, but there's 2 IP addresses in each log message. Now, what's going to happen if I run this query for the parse the regex without the multi, because I don't want to introduce the multi yet? What's going to happen with my results? When I run this query, what am I going to get? Am I going to get results that have the first IP? Am I going to get the results that have the second IP? Am I going to get results that have both IPs? Am I going to get results that have neither IP? So let's take a look. What's going to happen is I'm going to get the first IP. The system is going to go through the message and it's going to say, can I find number.number.number? Yes, I can. Here it is. Let me display it proudly. And now let me go to the next log message. Can I find number.number? Yeah, here it is at the first IP. There it is. Next message. And it's doing what it's being told to. It's looking for the first occurrence and then stopping essentially. Now, what if you want to look for more than one occurrence? In this case, we have 2 IPs. This is where multi comes in. Now, the way that the results are going to be displayed is going to be a little bit weird. I'm just going to tell you that, but let's see why it's weird. It's correct, but it is a little weird. So what I'm going to do is run this now. So here is my first log message. Here's the first IP, 2124.232. Here it is. The second IP address is 10.82. Here it is. So what's occurring here is this log message is being duplicated. Here is IP address 1, here's IP2, IP1, IP2. So even though it says I have 2,700 results, in reality, I have about 1,400 unique log messages. But the system is doing it correctly. And so it's going to look for each occurrence and retrieve it, and then display that as an IP. Now I'm going to show something here that this question usually comes up. So I'm going to try and get in front of the question. So here's the question that comes up. This way is very good. If I consider an IP address to be an IP address to be an IP address, then this makes perfect sense. But what if I do want to treat this as IP1 and this as IP2, or this is host and this is remote, or source and destination? How do I do that? Well, this is an example where a different parsing mechanism might be helpful. So what I would recommend doing here is using the parse UI that we did yesterday. And I'll just show an example. You don't have to do this. But what I'm going to do is I'm going to highlight a portion of the log message. I'm going to right click on it. And what I'm relying on here is the fact that this TCP is going to be static in every log message. This colon is going to be static. This arrow is going to be static. And so what I'm going to do is I'm going to highlight the parts that are not static. And so I'm going to create 4 fields off those. And I'm now going to give those fields a name. Source IP, source port, dest IP, dest port. And now when I run this query here, this is going to get me probably what I would expect if I have multiple IPs, where for each log message, here's the dest IP, here's the source IP, and now I could say, count the source IPs or whatever I want to do from here. But just wanted to show that it's a little bit of a tangent, but it's a question that usually comes up at this spot. So that's why I was just trying to get ahead of it. All right. Finally, field extraction rules. So let's talk about this. This is a very important feature. So let me grab the query and let's talk about what's going on here. All right. So before I run the query, let me show two examples. Yeah, let's do this. This will probably be a better way to illustrate it. Okay, yes, this will work. So what I'm doing here is I'm looking at my lab snort data. This is that data that we looked at earlier. And what I see here in the hidden fields, or the field browser, excuse me, are those fields that Sumo Logic's aware of. So it's going to be aware of the time, because it's extracting time from the log message. It's going to be aware of the message, because that's the whole point of Sumo. And then it's going to be aware of some of this metadata fields. We talked about these yesterday, things like source category. Now what I want to do is I want to pull up Lab Apache Access data. Now, when I pull this data up in my field browser, I have the time and message. I have the source category. But what I also have here are a bunch of fields. I have a field for status code. I have a field for size. I have a field for refer. We used that yesterday. I have a field for URL, etc. And so what is happening here is the system is aware of this log format, and it's doing parsing automatically. Upon ingestion, these log messages are formatted, or parsed, excuse me, and the fields are extracted, and we can utilize those fields. And that's what we want to demonstrate in this lab. So what I can do here is I can say, look for status codes that are equal to 404. The reason I can do this is because this rule is in place, this field extraction rule, as we call it. It knows that a status code is found in this spot. And when I do status code equals 404, it's going to look in this spot for a 404. Now, let me see if I can show an example. Yeah, here we go. So here are some that are set up. But let me show, where is it? Here it is, this one. So here is an example of a field extraction rule set up for Apache Access data. What this rule is saying is anytime data comes in with the source category of Lab Apache Access, at ingestion, apply this parse expression. And so this parse expression is saying, look for an IP address, look for the status code, look for the size, and so on and so forth. And then I can utilize those fields as I'm doing in this query right here. I can say count by source IP, because the system knows where the source IP is. It knows how to locate it. So field extraction rules are quite helpful, quite important. There's something we cover in the administrative course. So if you don't know how to set them up, we encourage you to do so. And so we want to introduce them to you today. So if you want to learn more, and I'd encourage you to, the administration course is probably the best avenue to do so. All right, there's a couple true false. Let's go through these. We didn't really go through these specifically in our examples, but the first one is CS, and these are true and false. CSV, JSON, split, key value are all parsing operators. So this is true. We just didn't really use it. So, but that is true. True or false? Once a field has been parsed, it cannot be parsed any further. So that's false, and I showed that as an example of the email address where we started to use some filtering there to look specifically for the address. Question, let me see, the good question. Let's see here. Let me just show, let me show the example to describe the question. Here it is. So the question is around the email, the parsing of it. What we're doing here with this parsing is we're simply saying, look before the at and look after the at. You could make this more complex and start to use regex where it says, if it has a question mark or something like that, filter it or include it or don't. You have those options. But here we're simply saying, take what's in front, take what's in the back, and create those into fields. So this can get more complex. It can get a lot more complex. But in this case, we wanted to just show it as a simple example. So I hope that helps answer the question. All right, so let's see, and back to the quiz. Fields parsed by the field extraction rules are available in the field browser, and that's true. And so that's what this is alluding to. Here are the fields that the system is aware of. All right, let's keep going. We'll do 1 or 2 more labs and then we'll take a break. So have a break coming up. Let's do lab 4. For this one, we're gonna do lab 4.1. The optional one is optional. I'll show the difference between the two. I won't do the whole lab for it. You can if you want. So let me go ahead and grab this query and let me show you what it's doing, because this is helpful. All right. So what I'm doing first is I'm looking at Lab Apache Access data as, once again, as we keep doing. Now in the second line, what I want to do is I want to start to utilize the status codes. Now in this case, I am using the parse anchor where I'm saying, look for HTTP 1.1, look for a space, that next thing is a status code. I do not need the second line. Since my field extraction rule is working, the status code is already being identified, but I'm going to assume it's not. So I can leave this line in, I can remove it. In this case, I'm going to keep it just because it works, but I could remove it and it would still work. But when I run this, what I now get are my log messages, and I get the status code that each log message has in it. Now, what I'm going to do next is I'm going to create a tallying system. What I'm about to do is create a new column or new field called successes. And I'm going to look at the status code that's in that status code column. And if it's a 200, I'm going to tally a 1. If it's not a 200, I'm going to tally a 0. So we're using binary or Boolean. We're essentially true or false here. So let's take a look at this. So I'm going to click Start. And now here's my first status code. Is it a 200? No, it's not. And so I get a 0 there. Here's another status code. Is it a 200? No, it's not. So I get a 0 here. Here's a 200. So I get a 1 there. All right. What I'm going to do next is I'm going to do basically the same thing, except I'm going to look at 404s. And I'm going to classify those as client errors. So when I click Start, I'm now going to have another new column called client errors. So here's a 500. Is it a success? No, it's not. Is it a client error? No, it's not. Here's a 404. Is it a client error? Yes, it is. And now what I'm going to do is I'm going to take those successes and add them up. I'm going to take those client errors and add them up, and I'm going to call them success count and client count. Success count and client error count, excuse me. What we're going to do a little bit later is use this as a ratio. If I tell you that there were 5,000 successes and 200 errors, is that good or bad? What we can do in the future is start to establish whether it's good or bad, and that's where we're headed towards. So this allows you to create a tallying system. Now in lab, or the optional lab, I just want to show the difference here. Here we're saying equals 200, yes or no. Here what we're saying is matches 4-star. So what I could do is I could classify a client error as something that starts with a 4, a 400, a 404, a 4000, a 405. Those will all be classified that way. So I wanted to show the difference here. We can use equals to look for something specifically, or we can use matches, which allows us to use the wildcard to match any results that match. So 2 different ways to do it. And what you'll see when we get to the last lab is we're going to use a lot of the features that we're showing right now in the final lab as a way to wrap everything up. So you'll see some of this again. All right, let's go ahead. Let's do lab 5 and then we'll take a break. Lab 5, it's not my favorite lab, but I want to show you what it allows you to do. What we're going to do here are utilize our subqueries. And if you've used SQL, you probably know how this works. If you've just used any programming language, subqueries are kind of a thing. And so they work here as well. What we're going to do is we're going to have one query run in the form of a child query. And that query is going to pass a result as a keyword to another query. So we're going to run 2 queries with one query passing a result to another. And so let's look at this. So let's say we want to look at our Apache access data and an IP address. So we're looking at our Apache access data for a specific IP address. Now for the IP address, we automatically want to look for the IP address that shows up in the Apache error logs as the file does not exist error. So what we want to do here is we want to look at our Apache error logs and we want to look for an IP address that shows up most frequently in the error logs, and then pass that IP address to the Apache access logs. So how do we do that? Well, that's what this lab is all about. So what we have here is the parent query and the child query. So let's go ahead and take the child query and run it, and then we'll add the parent query and show you how it ties all together. So once again, I'm going to copy, do a new log search, paste, do line by line comments. And on the first line, I'm going to look for my Apache error data and look for this text, file does not exist. And now I see those log messages. So log message with an error and file does not exist. What I'm going to do next is I'm now going to parse my data. I could do this in a few different ways. The way I'm doing now is one way to do it, where I'm saying, look at bracket, bracket. That's going to be called time. Look at the next bracket, bracket. That's going to be called error. Look at the next bracket. Look for the word client and look for that IP and call that thing an IP. So now when I run that, I am going to be extracting my IP addresses. Now what I want to do is count these IP addresses. How many unique IP addresses do I have? Now in this case, I only have one, but imagine this list was longer. Imagine this list showed 5 different IP addresses. It doesn't, but imagine it did. What we want to do next is we want to say, okay, find the top IP address, the top K, the top 1 by count. Top and top K are a little bit different, but it's the same idea. So now when I run this last line, what I should be displayed is the IP address that shows up most frequently, which is this IP address of 70.69.152. Now let's go back to our thing here. So what we have is our child query produced that IP address of 70.69. What we're now going to do is pass that IP address as a keyword to the parent. So let's look at everything all together. So essentially what we have is our subquery. And once it got through these steps that I've highlighted, it figured out that the IP address that was showing up most frequently is that 70.69. What's going to happen next is it's going to take that IP address and pass it as a keyword up here. And so when I run this, what should be shown in my results are Lab Apache access messages and the keyword of 70.69. Now, in this case, it's not highlighted as a keyword, but it is the only IP address that shows up because we're filtering it on it. So this is what we want to show you here. These subqueries can get much more advanced, much more advanced. You can have subqueries within subqueries. I just wanted to introduce it as part of the labs. like I said, it can get quite detailed. And if you're familiar with SQL, you know how deep subqueries can get. But just want to, like I said, show it and demonstrate it. So hopefully you found that helpful. Pretty simple example as well. All right. Let's see. Questions, I think we're pretty good. Yeah, looks like, yeah, we're doing okay. So why don't we take a break now? Let's do the same as we did yesterday. We'll do a 10-minute timer. So once again, we'll do a 10-minute break. I'll put myself on mute. Encourage you to grab a snack or do whatever you like to do. We'll come back and do 6 or so more labs, and then we'll take the exam. So thank you everybody again for attending, and um, I'll see you all in a few moments. Yeah, welcome back, everybody. Hopefully you had a good little break there. Um, let's continue. I don't see any questions in the chat. Yeah, so let's go ahead and keep going here. So we had just finished lab 5 here, which was going over the subqueries, or at least the idea of subqueries. Lab 6, I want to take a look at. Lab 6 we looked at yesterday, but in much more detail. We're going to go through it today. What we're going to do here is we're going to plot clients on a map. So we're going to use our geo lookup operator to plot a map. So as I've been doing, I'm going to grab the whole query and talk through it. You saw this yesterday, sort of, but like I said, we'll get into more detail with it now. So I'm going to do a log search and talk through these lines. Oh, didn't need all those. So in the first line, as we've been doing, lab Apache access data. And what I need for this to work are I need IP addresses. Now, how do we identify IP addresses? Well, we've done this a few times today. We used regex earlier to look for number. We used or can use the field extraction rules to look for the source IP address. What we're doing here, though, is we're doing a different way. We're saying look for something space dash space dash. If you find something space dash, that first something is going to be a client IP. When I click start, I should now get a bunch of fields, or one field, but a bunch of values for client IP. And I do. Now, this feature of this mapping is only going to work for public IP addresses, but let's look at it to see how it works and what it does for us. And that's going to be occurring on this third line. What we're about to use is a lookup table. Sumo Logic gives you access to a couple of them. This is one. This is really the only one we'll discuss today. But let's see how this works. This gives us access to geolocation, geographic data. The way that I want you to read this third line is to read it from right to left. I think it's easier. So what's occurring with this line? What is this whole lookup geolocation doing? It's pretty simple. What it's doing is saying, take the client IP, the value we just parsed out, and compare it to the IPs that exist in the geolocation lookup table, which is a table or it's a table that we host or own. From that table of data, extract out geographic data. There's a lot of different geographic data we can extract. As we saw yesterday, we can do country name, we can do latitude and longitude, which is what we need. And so we're going to go ahead and look up the latitude and longitude. So for each IP address, it's going to be looked up in the geolocation table. If it's found, it's then going to pull out or extract the latitude and longitude. So now what I have is each IP address and a latitude and longitude pair. What I need to do next is I need to count these. As you don't notice, but I'm going to point it out, we still have our messages tab, but we don't have the aggregates tab. We can't graph anything or chart anything until we get the aggregates tab. So the way that we can get to that aggregates tab is by doing a count, doing that mathematical operator. When I run this for count by latitude and longitude, what I'm going to get is latitude and longitude pairs and the counts. The count represents how many users came from that site, how many how many visitors, how many users, whatever you want to call it. But how do I plot these latitudes and longitudes on a map? Well, I do have some other charting options. The one I want to identify or point out is this one, this map icon. Very simply, click on the map icon. And now what I have is a worldwide map showing me where my Apache Access users are coming from. This map is dynamic and I can zoom in. So for example, here we're showing the northeast of the United States. If I zoom in, I now start to see different states, different regions, and more explicit. I can even get down to street level. So I wanted to show this because one, it's very simple, a simple query. To create this map, we had a source category. We parsed out the IP address, which we didn't even really need to do this second step because we were using field extraction rules. We then did the lookup, and then we just counted the results and then displayed them. So very simple, but simple in a good way. So like I said, I really like this lab. I think a map is very illustrative, easy to understand. And so that's how you do it. It's really that easy. All right, so let's keep going here. The other thing I'll just show, just one last thing with the geo lookup. So you do need latitude and longitude to do the map, but you can also extract other fields like we saw yesterday with country name, etc. So I could go ahead and do, actually, just to show it to you real fast. And so now here are my country names. And so now I could, like we did yesterday, I could say, show me where equals United States or doesn't equal United States or whatever. So, all right. That is lab. Let's see, question. If we want to group by geo country, how would we do it? Latitudes and longitude numbers are difficult to understand. Absolutely. So that's where using country name would be a great way to do it. Using country code. You can use region. So there's other ways to do that. So yeah, you could say country code only, group US and Canada together or whatever. So, okay, cool. Let's see, let's go to next lab 7. Come on. Why is my lab 7 not showing up? Why is this being weird? Let's see, lab 8 shows up. There's lab 7. Sorry about that. I'm going to skip lab 7-1. I'm going to skip it. It's just, you can run it. It's just not a very important feature. But this next one I think is a little more useful. What we want to do here is we want to look at the moving average of 404 occurrences over the last 15 minutes. And we're going to show a few things in this. So let's grab the query. And once again, let me talk through it as I've been doing. So new log search, turn these off, and go line by line. So in the first line, what we're doing is we're looking at Apache access data and we're looking for 404. So once again, it starts to get repetitive in that that's what we're looking for again. What we want to do now is introduce a feature called time slice. I think, yeah, we introduced this yesterday, but it bears repeating because it's quite helpful. Now, sorry. What the time slice operator is going to allow me to do is look at my data in groups or buckets of time. Because when I run a query for the last 15 minutes, I'm looking at my data in a bucket of 15 minutes. It might be from 10:30 to 10:45, 10:45 to 11, but it's grouped together. What I can do with the time slice is start to look at those 1-minute segments individually. How many results did I have at 11 o'clock? How many did I have at 11:01? How many did I have at 11:02? And I can start to look at that. And that's what we're showing here. So I'm going to introduce the time slice as an operator and define this segment of time. Then I'm going to count. I'm going to count the messages and call those new messages, or not new messages, but those messages error count. And I'm going to group them by time slice. So when I click start, I'm doing count, I'm doing aggregation. I see my counts, my times, and I see my error counts. So this is saying here in this 1-minute segment, I had 15 404 messages. What I'm going to do now is sort these. And here's another example of using the underscore from the operator. So here's the operator of time slice, and here is the value of that result. I'm going to sort them, and I'm going to sort them in ascending order. So what I now have is my times and my amount of 404s. Now the smooth operator is going to take the error count and create or turn it into a rolling average. And so very simple math here, but let's go through it. At 10:50, there were 17 error messages. The average of 17 is 17. At 10:51, 17 plus 22 divided by 2 gives us a rolling average of 19.5. Here we take 17 plus 22 plus 17 divided by 3 to get this value. Now what we show you here, or have you try, is the column chart, the line chart. These are both good ways to express this data. But what we want to show in this lab specifically as a bonus is plotting these as a line bar combo chart. So I see how to put my data in a bar chart. I see how to put my data in a line chart, but how do I get a combo chart, which means to use both charts at the same time? Well, what I can do for my charts is I have this gear icon. And under it, based on the type of chart that I'm in, I have different options. What I want to show here is this option of change series. What this lets me do here is decide what chart type I want to use. So here I can say for my error count for those 1-minute segments, use a column chart. But for my rolling average, use a line chart. And now when I click save, I get both. The bars represent the minute, how many errors I had in that specific minute. And this light blue line represents the rolling average. It's pretty level. It goes up, it goes down, but it's pretty consistent. And so that's what it's showing me here. So I want to show this, the ability to use some of these options. There's other things in here. You can change the legend. Changing colors is always very popular. Just other things to make it more familiar. All right, let's go on to lab 8. Now, lab 8, lab 8, this portion, let me show this first. This is going to be log reduce. We actually looked at this yesterday. If you remember my demo, we used this feature, but we're going to show it again. So let's look at it and see why it's helpful. So before I use the feature, I want to look at my snort data. And for this data, I want to look at the last 60 minutes. It's just going to get me a little more data, just more data, better. Now, what I want to point out about this data is earlier we used this data and we used the fact that it had 2 IP addresses in it. That was really why we were using this data. We're going to use it a little bit differently now. What we're using it for now is these classifications. If you notice, every log message has a classification, and these are different security events, I guess we could classify them as. So here's the attempted intrusion leak. Here's the detection of a network scan. Here's an attempted information leak. Here's another attempted information leak, so on and so forth. And I have 6,000 log messages. So possibly a lot of different classifications. Now, what if I want to get a quick understanding of these classifications, these groupings, these patterns that exist within these log messages, all 6,000 messages? How do I get some patterns through them? Well, this is where log reduce can help me. What I'm going to do is I'm going to click log reduce, or I can type it into the query window. Same difference. When I do, what's going to happen is the system is now going to look at the data for the last hour and look at those 6,000 log messages and group them together based on patterns, and then show me those patterns. And it's just about done, finished. Yeah, just finished. So what it now shows me is, for example, this attempted information leak showed up 3,000 times. This web application attack, showed up 1,500 times, and so on and so forth. So what log reduce does is, as just mentioned, it takes those various log messages and looks at patterns in each log message and then groups those patterns together and allows us to see those groupings or those counts. So I want to show that here. It's a really important feature for Sumo Logic. We got our first patent on it, so it's something that was quite important for our company as a whole. And so we start to see these groupings here. Once again, I could have also put the log reduce in there as well. So. All right. Let's see if there's any little question. Not a little questions. Any questions about it? Nope. I think we're good. All right. Now this next feature, this is lab 8-2. Can we put a filter in log reduce? Sort of. Let's go ahead and like error. Yeah. So let's let me see here. Can you put a filter in log reduce like error? That's a good question. Let me think on that. Yeah, let me think about that, because you can filter it first and then do the log reduce. So you could filter it for the keyword of error and then run a log reduce. That would probably be the best approach. Yeah, I think that would get you to where you want. What I want to do is I want to jump to lab 9. And what I want to show is a feature that utilizes log reduce, but takes it a step further. And this might help with the filtering question, although it doesn't. But let's take a look at this. What we want to do is we now want to introduce a feature called log compare. And what I want to do is once again now show why log compare is helpful. So let me take this. And for this example, I am not, let me think. I'm not going to use the source category lab Apache Access. I'm going to use the source category lab snort. So let me show you what I'm describing, because I don't think I'm describing it very, very well. So let's go back to our log reduce. So I'm looking at my snort data like I did earlier. And I see that this attempted information leak showed up 3,000 times. Now, the question to you is, should I be concerned about that? Are 3,000 attempted information leaks in an hour concerning? So think about that for a second. Is that a concern for me? So the answer is, it kind of depends. If I am a small mom and pop shop and I have a server in the closet, 3,000 attempted information leaks in an hour is probably quite a lot and might be quite substantial. If I'm Google, 3,000 in an hour is probably nothing. So what I want to do is I want to compare it to something else. I can't really tell you if it's a lot. I need to compare it, and I want the system to help me compare it. And that's what I'm going to use this log compare feature as, or for rather, not as, but for. Right now, I'm looking at a 60-minute window. So I'm looking at, for local time, I'm looking about from 10 to 11 o'clock. What I want to do with log compare, or what log compare will do for me, is go back automatically to the last 24 hours and look at all those log messages from 10 to 11 o'clock yesterday and group those together based on patterns. And now it's going to show me the result and the difference in this form of this value here called a delta percentage. What I'm seeing here is between yesterday to today, I had 0.78% less attempted information leaks than yesterday. So I had less than yesterday, which is good. Conversely, I had 2.7% more web application attacks, which might be bad. But now I'm starting to be able to compare these things. The log compare, well, it does do 24 hours by default. You can customize this. And so you can start to put a query in here and start to use some filtering to say, compare this period of time, compare this set of data, excuse me, compare this other set of data between this period of time over this time range. So this delta percentage, as we call it, is quite helpful. Another place that's going to be helpful, let me see if I have an example here. Perfect examples. Is I see those messages that are new as well as those messages that are gone. And what this means is, if it's new, that means it showed up today, but it did not show up yesterday. And usually you guys are, you people, but you guys want to know when things are new, because usually new is not good. Not always the case, but usually it's not. And so this is a way that you can start to see those new events that did not happen previously. What you can also see are those messages that are gone, meaning yesterday, this suspicious file name was detected, and today it's not. So want to show that. So that's what's occurring in this lab 9-1 is we're taking our set of data, whatever it is, and we can use our filters in here, and then saying compare it to a 24-hour time shift. You can change that to any time shift. You could do last 7 days, but 24 hours is the default. In this lab, what we're doing is we're saying look for that delta percentage when it's greater than 25. So for example, do I care that something increased by 2.7%? I might, but I might not. Maybe I only care if it really increased by 25% or more. That's more meaningful to me. And so I can say only show those that increase by 25%. And so there I see these. And then the other portion, which I had just showed, is the is new, where you could say, just show me those things that are new or is new. All right. I know we're throwing a lot of operators at you. I know this is a lot of material. Thanks for sticking with it. We have a few more here that we want to show you. This next one is, I don't know if it's the most important feature of Sumo, but it's very, very highly up there. It's called outlier. And what it's going to allow us to do is look for out of the ordinary events. So let's take a look at how this works. Once again, I'm just going to go through the example. So I'm going to paste this in. I'm going to modify this query just a tiny bit, just for illustrative purposes. And let's go this line by line again. So what we're doing is we're looking at the last hour's worth of data for Apache Access 404s. Once again, we're going to time slice them and count them. So based on the time slice, we're going to see a 1 minute time period, and we're going to see how many 404s occurred in that 1 minute time period. So as I asked earlier, here we have 20, we have 14, we have 15 404s. Is that a lot or a little? Is that concerning or not? Is that abnormal or not? Well, I don't really want you to answer. I want the system to help me decide that. I could arbitrarily say 20 is a lot, but I don't want to. I want the system to determine it for me. So let's look at how we do that. And that's what this outlier operator is going to do for us. Here I have the outlier, which is the operator. I'm going to run the outlier operator against the error count. And I'm going to perform all this math against it. I'm going to refer to it as math for now. I'll get into it in a more depth just in a moment, but for right now, I'm just going to call it math. So I'm going to search. And I'm going to have the system start to determine what's normal and what isn't using the math. And it's now started to do so. So let's see what's happening. Here, for example, in this minute period, we had 12 error counts or 12 404s. The math is determining an upper and a lower, or here's the upper, here's the lower limit of what's acceptable. It's saying based on the math, between 4.5 and 25 404s is normal, acceptable, good, whatever word you want to use. We had 12 during that period, and so that's normal, that's acceptable. The next time period, the math changes the range a little bit. It's getting a little bit tighter. Now it's 4.6 to 23. 20 is within that range, and so that's once again considered good, normal, acceptable. Let's fast forward a little bit. Here, the range is between 10 and 22, or actually 23. The actual error count was 24, meaning we had more 404s than the system was expecting. And so what the system does is it flags an error count violation here. Now, this is an okay way to view the data, but this line chart is going to be much more valuable. What I see in this line chart is, a few things. I see this this blue line that's representing the error count for the specific moment in time for that 1 minute period. I see this cloud with an upper and lower limit, which is representing the threshold or the range of what's considered acceptable. And then what I'm saying are these pink triangles, which are representing the fact that at that point in time, things were not normal. They were outside the range. So what I see here is over the past 60 minutes, the system has determined that there are 4 abnormal times. 2 times where we had more 404s than were expected, and 2 times that where we had less 404s than were expected. Now let's talk about the math. Here, for example, is direction. Do I want to look above the cloud or below the cloud or both? Now, in this example, the fact that I had less 404s than were expected, that's a good thing. That's not really a bad thing. And so what I can say with my direction is only show me plus. Now, when I run this, I am only going to have those pink triangles on the top, not the bottom. Another way to change this is with the threshold. This outlier gets very mathematical, and I'm going to keep it a little vague, but it does get quite into math. And what the threshold is essentially is standard deviation. How many standard deviations do you want to perform against your data? When I change it, it's going to change not my counts, but my range of what's acceptable. So let's change it. If I go from a 2 to a 1, I go from having 2 bad periods of time to having, I don't know, what, 10 or so, 15? And so I can now utilize this threshold to say, show me a different range. In this case, I'm going to use a wider range, and now I have no errors. My error count isn't changing, just the variables or the values that I'm using to calculate the math is. And so what we would encourage you to do is use the default values and decide, are you being alerted too frequently? Maybe change your threshold. Are you not being alerted frequently enough? Maybe change another value. And so now the system is letting us know. Now, why we use this versus using a static number is because this is dynamic. I could put a rule in that says, if I have more than 25 404s, alert me. That's quite easy to do. The problem with that is it doesn't grow with me. A month from now, my traffic could grow 10x, and that 25 value could be meaningless. But this outlier operator grows with us over time. And so it allows us to dynamically see or have the system determine what is acceptable and what isn't. We're going to use this operator in the lab in a little bit later to tie all these things together as well. So you will see this again. So I wanted to introduce this. It's a really important operator. It makes the system do the hard work of determining normality. So, all right. Let's take a look at lab 11. It's very straightforward in a good way. What this is going to allow us to do is use the prediction operator so that we can have the system start to predict what's going to happen. So I'm going to do a new log search. In this case, the first 3 lines are exactly the same as they were with the outlier operator. I'm looking at my 404s, I'm counting them, I'm grouping them together, but now I want to start to predict what's going to happen. And so I can actually use an operator called predict. When I do it or run it, it's going to start to do some prediction modeling. Here's the actual error count. Here's the modeling, and here's the prediction kind of accuracy, I guess you could say. But if I put this on a line chart, what I see here is the actual things that have occurred over the past about 10 minutes or so, and then what's expected to occur. And so what this is showing me is looks like I'm going to have a decrease in my amount of 404s, which is good. If this was spiking up, that would mean that I'm about to have a lot of more 404s, which would be bad. And so then I might want to do something in preparation to enable more servers or whatever you do to mitigate against 404s. All right, so any questions? I think we're pretty good on those. I'm going to skip over lab 12. I want to talk about it, but I don't want to show it because the example doesn't work very well. You're actually welcome to try it. It might work now, but I was having problems with it earlier. But I do want to introduce the idea. And so then in the future, if it's something that sounds interesting, you can use it. What this is going to allow you to do is, as it says here, analyze related log messages. We're going to use what's called a transaction operator. And what it does is it allows you to group messages together based on a transaction ID. like a session ID, an IP address, an order number, something like that. And what it allows you to do is to group messages into different states or groupings. And then what the transaction operator allows us to do is start to see these various states as they occur as users interact with them. So for example, let's say we have an order, an e-commerce website. People go to that website and they can order widgets. What this can do is we can go ahead and look at the logs, look at the IP addresses and transact on that IP address, and look at these various states: confirmation state, order ship state, putting things in the cart is a state, shipping info, entering that as a state, billing info is a state. And what we can ultimately do is use that transaction operator and then start to get our data in a graph that looks, or a chart that looks like the one I'm showing right here, where we can see this many people reached the carting stage. These many people got to the confirmation stage. These many people got the order ship stage. Now, we can't necessarily tell you why they were not able to get from cart to confirmation, or why they only could get the shipping info, but you're going to start to see that people could get to various states or could not. And so then you can start to use that information to figure out what's wrong with one of those states. Is there an issue why people can't get to the ship order ship page? Is there a error in the code? Is the shipping amount too much and people just don't want to pay that much? And you can start to evaluate your data and utilize it. So wanted to mention this feature. The lab, like I said, just is a little flaky. So that's why I just don't want to show it. You're welcome to try it. It might work. But just in the essence of time, I'm going to kind of skip over it or gloss over it. Because what I want to do is I want to finish up with lab 13, which is creating a meaningful alert. Now, this lab is going to take things that we've done already today, many things we've done already today, and combine them into one big lab. And so I think it's a good way to finish. What we want to do in this lab is, as it says here, rather than alerting on a simple count, is we want to create an alert when we look at our traffic, we look at 404s, and we're seeing those increase at a higher rate than our overall traffic. So what we want to do is, rather than saying 10 404s are bad, we want to look at successes, which are 200s. We want to look at fails, which are 404s, and start to figure out a ratio and start to see what's going on and see when things are good and when they're bad. So that's what we're going to do with this big query. So I'm going to copy the whole thing and paste it in, but it should look very familiar to you. All right. And this is the last lab. I know you guys are getting, this is a lot of info. So thank you. Thank you for sticking with us. All right. So what we're doing in this first line is we're looking at our lab Apache access data. I'm going to do it for the last hour, last hour, just to get a little more data. And I'm looking for status codes that have a 200 or a 404. So in this case, I'm looking for one or the other. If it's a status code of a 500 or a 403, I don't care about it for here. I'm going to use my time slice because I want to group this data into buckets of time. And then I want to use the tally system that I was using earlier, where I'm going to look at the status code. And based on if it's a 200 or a 404, I'm going to tally a 1 or a 0 in the fail or the success column. So here's a 200. Is that a success? Yes, it is. And so we see a 1 in the success column. Is that a fail? No, it's not. So we see a 0. Here's a 404, and we see a 1 in the fail column. What I'm now going to do is take all these counts of successes and fails and add them up, but I'm going to do it by time slice, because what I want to do is now start to develop a ratio. Because until I do that ratio, if I want to compare 1102 and 1101, it's kind of tricky. Here I had 430 successes and 15 fails. Here I had 461 successes and 16 fails. One is better than the other, but which is better than the other? It's a little bit hard to say. What I need to do is figure a way to convert, at least in English, apples to apples, a way to make sure that we're comparing things on the same level. And so what I'm going to do here is I'm going to take my fail counts, take my success counts, add them up, divide them, and then multiply by 100 to get a failure rate percentage. Because now I can see, in a moment, At 1119, the failure rate was 4.3%. At 1102, the failure rate was 3.3%. One is better than the other, and now I can start to make sense of it. Now, what I want to do next is I want the outlier operator to look at these values and tell me what is normal for my failure rates. I'm going to change this threshold to a 2, just the data presents better with a 2 in there. And now I'm going to use the outlier operator against the failure rate percentage. And so now what I can do, I can see this here, but I'm going to go ahead and look at this with the line chart. And so what I now see is the blue line is representing the failure rate percentage. The cloud is representing the upper lower limits of that percentage based on the math. And the pink triangles are now telling me when I'm above that limit. And so what this is telling me is over the last 60 minutes, there were 5 1-minute periods or 5 time slices where I had more 404s than were expected. So essentially those were bad times, bad periods. So that's what's being displayed here. Now this is very valuable information, but the lab's not finished. The goal of this lab is to create meaningful alerts. At this point, I now have meaningful information about past data, but I don't have the alert mechanism, and that's what I want to add right now. So let's go ahead and do so. It's quite easy to add. What I'm going to do is I want to trigger off this field. I want to look for when there are outliers. So what I'm saying here is show me where the failure rate percentage violation, this field, is greater than 0, meaning it's 1. So now when I run this, what I'm actually going to get is those past events that have occurred, those 5 bad things that have occurred. But I remember I want to turn this into an alert. And so that's what I'm going to do now. And so what I'm going to do is, as we did yesterday, I'm going to choose to save this. And I'm going to choose to schedule this search. And then I'm going to check the frequency. And so now, actually, I wanted to choose real time here. I'm sorry. I want to choose real time here. And the reason I want to do that is if the following condition is met, meaning there was a real failure rate percentage violation occurred, then I can send an email. So what can now happen is now the next time I have that 404 spike, I get an email, or my ops team gets an email, and maybe they go ahead and reboot a server or stand up more servers or do whatever they need to do to mitigate against that spike in 404s. So I want to show that as a way to end today's labs. Just because I think it ties everything, I think it does tie everything together, and is also quite useful. So I'm going to pause here. We're pretty much done with the content, the lab, so I'll see if there's any questions. Okay, so let's go ahead and continue. Let's start to talk about the exam. So if you took yesterday's class, you may kind of know what you need to do here. So feel free to kind of jump in and start doing it. But let me go through this more specifically. So what we want to do is we want to take our certification exam. Now, as a reminder, we don't want to take the exam as the training user, the training analyst. We want to take it as ourselves. And I believe everybody here has their own Sumo Logic account or has one from an employer. So what we want to do is we want to log out of our training account and log back in as our real user. If you're using Okta or something like that, then you may not have to actually type it in. And my password. So once you get logged in, you're going to go to certification. And you're going to choose or select Get Certified. Once you do, you'll then be brought to the certification page, or the portal rather, excuse me, the training portal. One thing I want to point out is if you go to recorded live training, I don't think I mentioned this yesterday, or maybe I did. And specifically the class we're doing, which is Search Mastery. Here are the additional materials that we used. Or it should show up here. There it is. So here is a recording of the class. Here are the slides, and here's the lab guide. So just wanted to show that. That's not required, but might be helpful. But what I wanted to show is coming into the Get Certified page. So you'll go to Get Certified. Yesterday you did fundamentals, so hopefully it shows registered. It should also say completed, actually, if you passed. Today we're going to do Search Mastery exam. So you're going to select the exam. You're going to register. It's going to give you some guidelines. You'll click next, and then you'll start the exam. The exam is going to consist of about 30 questions. You need a 75 to pass, so about 23. Let's see. Yep, 30 questions. Once you're done with the exam, you're going to want to make sure that you click the submit button. That's going to be important to do. This exam is also going to be open book or open resource. So as all of our exams are, you do have the ability to utilize the Sumo Logic resources. So I'd encourage you to use, of course, the documentation. But the other thing I'd encourage you to use, and I should have showed this earlier, is this cheat sheet. What this cheat sheet contains are all the operators that we have. We didn't go over nearly enough of them today, but we went through a bunch, and we went through the important ones that we want you to point out. So this is a list of all of them. So if you want to know, well, this is where it is. All right, let's see a couple other things here. Is the reward. Let's talk about this real fast. So as a reminder, once you're done with the exam and you've passed, go ahead and fill out this form. If you did it yesterday, you can do another one today. And what you're going to do is once you pass the exam, you're going to fill out the form. You're going to attach your certificate if you can. If you can't, you can still fill out the form and just not include the certificate. And then submit that form, and then that will be sent to us, and we'll get you your Swiggy voucher. So that concludes today. I'll stay on the line for a few minutes to make sure that we're all settled. Then I'll probably jump off. As mentioned, it's getting a little late here in the US. But thank you for attending. Thank you for interacting as well. We had some good questions. I know I didn't let really anyone speak about with the questions, but through chat, through Q&A, they were good questions. So let's start the exam. Once again, thank you again. Thank you for attending. And we'll also follow up the class with an email that should contain a link to the recording as well. So you'll get that, probably you'll get that on Monday, just being honest. Oh, and if you have problems with the form, good question. I'm going to have you send the email to just training@sumologic.com. Yesterday, I think I said training dash promotion or plus promotion. Just send, if you're having a problem with the form, training@sumologic.com is fine. And just tell us what problem you're having. And you'll get a reply. We're US based, so or at least the person who does the form, so it just may be delayed a little bit. All right, so once again, I'll put myself on mute. I'll leave this screen up for a few moments, and then take the exam. Once you're done, of course, feel free to leave. Congratulations on passing. Thank you for attending, and we'll be doing another round of these India trainings probably in another month or two. But it's more convenient for you for your time zone, and I enjoy doing them. So we'll do these again. So thank you again, and best of luck. The last thing I'm going to point out, just somebody in the chat asked, that's a very good question. How to keep track or stay up to date on when the trainings are. I just said, put a link in the chat for our website that has classes coming up. And so here we're booked through April. This will become updated sooner. So keep an eye out on this page, the sumologic.com/learn/training for all the latest sessions. And typically we'll also, if you've attended a class, if we're going to be doing something in your region, we'll typically let you know as well, not in a spam way, just kind of a FYI. So good question though. Thank you.